Hello, 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 ladies and gentlemen, and welcome back. Welcome back. We're up to question number 8 as we continue our look at the 2013 MMC, the grade 12 level Manitoba Math Contest. Let's see. Let A, B, C, X, Y represent distinct non-zero digits. Consider the following subtraction and specific example taking ABC to be 4, 5, 2. So ABC minus CBA, they're just reversing the digits. And when we do that subtraction, we get a 1 and then XY. So for example, here we have 452, 254, 1, and we get 198 when we subtract. Okay. So there are many possible ways in which values can be assigned to A, B, and C so that the resulting calculation is correct. A, prove that X equal 90 and well, not 90, but X equal 9, but it is in the 90 position, and Y equal 8, so we get 98 here. So we're saying prove that you always get 198 regardless of the particular values of A, B, and C. Okay, interesting. And then B part, how many ordered triples A, B, and C are possible? Alright, so that just sort of finishes things up. So we want to show that 9 and 8 are the only things you can do. Well, I'll tell you what, they've got this, they've written it sort of the way you subtract in grade school before they give you calculators. 1xy. But I would probably instead write this as 100a plus 10b plus c minus 100c plus 10b plus a is equal to 100 plus 10x plus y. Okay, and actually, let's ignore this for a moment, because I've seen this come up a lot. I mean, there's lots of contests where they do things where you reverse the digits, so you get used to this over time. But what have we got? The 10b's will cancel out completely. We'll be left with 100 minus a, or 100a minus a, which is 99a, and we'll also get 90 minus 99c. And so it's a multiple of 99, we just need to know what A and C are. But, and here's the sort of crucial thing, 1xy is between 100 and 199, and it must be a multiple of 99. So 1xy has to be 198. That's the only multiple of 99 in this range. It's the only multiple of 99 that starts with a 1. This 1 is key. I think there are other possibilities. Depending on your A and C, you can get other things, but they would start with 3s and 5s and 2s. And so that tells me x has to be 9 and y has to be 8. So we get 90 and 8. Okay, so that wasn't that bad. We said they sort of gave the subtraction in a weird way, I think. 1, to emphasize that they are digits, and 2, to sort of obscure this calculation, because I think if they set it up like this, it would have been incredibly obvious what to do. So part of that was we need to translate it in the right form to talk about this, but getting 99 as a getting 1xy as a multiple of 99, I think makes this question trivial. Okay, so that was prove that x is 90 and y is 8, regardless of the particular values. How many ordered triples A, B, C are possible? Okay, now here I want to be very clear, because they said distinct digits for all of them. So I can't let A, B, or C be 9 or 8. Now, sometimes, not all the time, but sometimes on math contests, people aren't reading it the same way you are. Okay, and so, you know, by the time we get to B, it might not be obvious that it should be distinct still to the person who originally made the question. And so they might be saying, where's the A is 9 case? And now, I guarantee you that's not the case here, because they bothered to underline distinct non-zero digits, probably to avoid this issue. But anytime, and the reason I'm bringing this up is just because I feel it'll come up organically right now, anytime you feel like you're interpreting a question different than what might be the original, first stop and say, okay, why am I possibly interpreting the question different? You know, the Manitoba contest is reviewed by people. Okay, There are people who, somebody proposes a question, other people say, okay, let's change the wording here. No, I think that's too hard. Let's add in an A part to make this easy, that sort of thing. This is reviewed. So it is clear to the markers what's going on. So why do you have a different interpretation? Now, maybe you have a perfectly valid interpretation, but stop and think, is the way I'm interpreting the question, is the assumption I'm about to make the one that should be made? Is it obvious? Does it go against what they do? And if you can say to yourself, yes, I still think this is a valid interpretation, but you're worried that it might be different than what they think is what they want, it's hard to read somebody's mind. So you don't always know exactly what's wanted in every question. But if you're going to make an assumption, write down that assumption. So I would start off B by saying, remember that they have to be distinct. So A, B, or C cannot be 9 or 8. Okay, so I would start that off and make that very clear. I think that's clear in this question just because they have distinct and non-zero underlined. So I would say something like A, B, C. So there's 1 is less. So 1 is still allowed because neither X nor Y is 1. But I will say something like 1 less than or equal to A, B, C less than or equal to 7. Since 0 isn't allowed, X is 9, Y is 8, and the digits must be distinct. I'm just writing that down. One thing that I think would be completely bogus is if they said, no, A, B, and C can't be 1 either. Because there is no way you can read this and conclude that A, B, or C can't be 1. All I can say is A, B, and C can't be 0, and they can't be 9 and 8 because of what happened in A. So just because there happens to also be a 1 in the expression does not mean 1 is disallowed for A, B, or C. And that would be a problem on the part of the person who's marking it if that were the case. But again, I'm pretty sure that's not the case for this question. Okay, so we know we've got a range for A, B, and C. Now, 198 is 99 times A minus C. But 198 is 99 times 2. So A minus C must be 2, and that's really the only condition. The B's don't enter into it at all. Okay, if I have 341 and subtract 143, I'm still going to get 198. And if I do 371 and 173, I'm still going to get 198. The B's don't matter. They cancel each other out. Okay? So, A minus C must be equal to 2. That's really the only condition. So what I'm going to do is I'm going to make a little chart of my possible C's. And then my A's, which must be C plus 2. And then I'm going to say allowable B's. Because B can't be equal to A or C. Okay? So as soon as I pick a C, now I can get A is 3. So B can be anything but 1 or 3. So it could be 2, 4, 5, 6, or 7. It can't be 8 or 9. Okay? If C is 2, then we get 4. And so it can't be 1. B could be 1, 3, 5, 6, or 7. And we're going to keep going like this. We'll get 5, we'll get 6, we'll get 7. But as soon as I hit C is 6, A would have to be 8, that's not allowed. Same, we'd get 9 here, that's not allowed. But I'm pretty sure we're going to get 5 different B's for each pair A and C. We'll just double check this. 5 is not allowed, 7 is allowed. Oh, 6 is allowed as well. 6 and 7. Here we can have 1, 2, 3, can't have 4, can have 5, can't have 6, can have 7. And 1, 2, 3, 4, 6. So number of possible ABCs, 5, 5, 5, 5, and 5, for a total of 25. Now they just wanted the number, right? How many ordered triples A, B, C are possible? So I would say my final answer is 25. I might sum it up and say there are 25 possible triples A, B, and C. And if you wanted to, you could you could honestly write them all out. I'm not going to because there's 25 of them, but that's entirely possible. You could certainly do that. What the heck, I got time. Let's write them out. It'll be 4, 7, 2 here. It'll be 5, 7, 3 here. It'll be 6, 7, 4 here. And it'll be 7, 6, 5 here. Alright, and these ones will all have 1 in the middle. It'll be 4, 2, 5, 3, 6, 4, 7, 5. So we'll have 4, 2, 4, 2, 4, 2, 5, 3, 6, 4, 7, 5, 7, 5, 7, 5, 6, 4, 5, 3. Isn't this fun? But, it adds a sense of completion. And sometimes, I know at least when Waterloo is doing contests, because I'm more familiar with how they mark things than the Manitoba contest, but sometimes with Waterloo, it's you can get part marks based on how many of the actual answers did you get, in case you missed some or added some things in. So 3, 5, 6. This will also be a 6. This will be a 4. And this will be a 2. 2, 3, 5. 2, 3, 4. So those are our possibilities for A, B, and C. Okay, and that wraps up question 8. So we will move on in our next video and take a look at question number 9. I will see you guys for that one in the next video. Have yourselves a wonderful day in the meantime.